Okay, so we're going to work on this problem. So what we're trying to do is find the exact value of sine u plus sine v. And I have some information about u, which is the sine of u is equal to 4 over 5. And it's in quadrant. That means it's in quadrant 1. Okay, so we're going to start there. If I draw a triangle in the first quadrant, the interior angle is u. Sine the opposite over the hypotenuse is 4 over 5. I can solve for the third side using Pythagorean. So x squared plus 4 squared is equal to 5 squared. So x squared is equal to 25 minus 16. So x squared is equal to 9. So x is equal to 3. So our x length is equal to 3. So remember from trig, this 3 is equal to the cosine of u. This is equal to the sine of u. Okay, but we have a problem because normally our hypotenuse is equal to 1. So if we have a hypotenuse that's other than 1, then we have to scale down our triangle. So this is actually 3 over 5, 4 over 5, and 5 over 5, which is equal to 1. Okay, so we get the cosine of u and the sine of u. Okay. So next, we're going to look at the second triangle over here. We'll make it green. I get cosine v is equal to negative 13 over 12. And from pi over 2 to pi, so that tells me quadrant 2. Okay, so I'll draw my triangle in quadrant 2. Cosine is the x, so negative 12, and then the adjacent over the hypotenuse, which is 13. Then the angle here is v. So when I have an angle v, I have side lengths of negative 12 and 13th. How do I solve for the third side here? Pythagorean. So negative 12 squared plus y squared is equal to 13 squared. So 144 plus y squared is equal to 169. So y squared is equal to 25. Now take the square root. Y is equal to 5. Okay, so we can actually make this a little bit quicker. If you remember that when the hypotenuse is not 1, we can call this r sine v, and this is going to be r times cosine of v. So remember, what was our r value? Our r value is 13. So divide by 13, divide by 13, divide by 13, and we get our sine and our cosine. So now we can go ahead and evaluate. Our sine of u plus v is equal to the sine of u times the cosine of v plus cosine u times the sine of v. Okay, and luckily we did all this work above to get our sine and cosines of each of the angles. So let's go ahead and evaluate. Sine u is 4/5. That was given. Cosine v right here is equal to negative 12 over 13 plus our cosine u is 3 over 5 times our sine v, which is over here, which is 5 over 13. Okay, now we're just going to go ahead and evaluate. So multiply straight across, so we get negative 48 over 65 plus 15 over 65. And we get negative 33 over 65 from common denominators. Okay, so we know that the sine of u plus v, so when I add these two angles together, then we're going to probably be in the third quadrant, and our sine length is going to be negative 33 over 65. And that's the answer. Okay, we're going to look at the next problem. We're going to do the co-function identity. So we're actually going to prove this. I gave this identity to you guys on a piece of paper, but we never really talked about how it works. So using our trig identities here. Okay, so you remember, start with the more complicated side. So we're going to start with this side. Okay, and we're going to try and make the cosine pi over 2 minus x look like sine of x. So I can see that my input is being added together. So we're going to make this our a and our b. So we're going to get the cosine of a minus b is equal to the cosine, it's also cosine a times cosine b plus, it's always opposite the sign you have here for cosine, sum and difference of cosine, and then sine a times sine b. Okay, so remember we need to use this. Okay, so we're going to do the cosine of pi over 2 minus x is equal to the cosine of pi over 2 times the cosine of x minus the, plus the sine of pi over 2 times the sine of x. Okay, so a and b, a and b. Okay, and you may be thinking like, oh, what do we do now? But we can evaluate these, right? Because those are just values. We're just looking for the ratio at pi over 2. So pi over 2 is 90 degrees right here. So that's the ordered pair 0, 1. So the cosine of pi over 2 is the x value. So that's 0 times the cosine of x. So that's cosine of pi over 2. And remember that one is the sine of pi over 2. Okay? Plus the height from the middle is 1 times the sine of x. So what happens to the first term? It goes to 0. So we get the cosine of pi over 2 minus x is equal to sine of x. Ta-da!